If you click on this video, you most likely are interested in learning deep learning in 2025, which I believe is a great thing to do given how things are unfolding on the AI front. In this tutorial, I'll show you how you should go about it when you have zero knowledge about the field. I'm assuming here that your goals are purely to learn enough of the concept to build something with the technology. For those new to the channel, I'm Yassine, a published researcher and machine learning practitioner who loves to teach. Before we start though, let's take a quick detour to review the current high-level state of AI. If you have this feeling of being a bit lost about the tech job market, whether to pursue a formal AI education or to even learn technical skills like programming, you are not alone. To give some color here, the overall consensus at Neurips, one of the top conferences in deep learning, is kind of bleak. Okay, so you can see this feeling distilled down in this blog post by Kyung-Gyun Cho. I don't know him personally, but like he is in AI and he was at Neurips 2024. And he put it pretty well, the general feeling. So you can see here like a lot of people were confused about the job market that feel much different when they started their actual PhD. Back in the days, there were just a handful of labs that were doing deep learning, like seriously. So there was kind of competition by Google and then the likes to recruit these folks. And you could see this when you were taking courses because all of your teachers were affiliated also to Google or Facebook. It was the case in my years with Doina and Joël Pinot. And you can see here, like they were recruiting folks just in case that something happened in deep learning. So a lot of people were doing research that was like kind of nice and they were well compensated and they were just there, which is starkly different from now where the R&D spending is like kind of cut in most area. And everybody need to contribute to the bottom line or something like that. So of course, there was a arms race for everybody to kind of train more of these PhD students. So a lot of them were trained. So that's kind of it. And then after that, what happened is that like the reality has come to pass, and then we have the LLMs right now, and there's a product to be built around this, like $1 billion product. So we're more in a productionalized zone than something else, right? We're not in the R&D kind of mode anymore. I think we're gonna go back to R&D at some point, but like now it's more about like building product, which doesn't necessarily require a PhD. They're not that good. A PhD, a researcher is like usually best when they have kind of a freedom to operate and then do stuff. If you want to productionalize, you're much better getting somebody with a master that knows this stuff. So yeah, like companies don't need that many PhDs as before. Since they can recruit bachelor or master student, we can contribute immediately and directly to the AI-based product following the standardization process. Yeah, that's the current situation at Neurips, which is a good kind of pulse on the whole AI and deep learning kind of community. So we are in a very weird period of time. The hype is like through the roof, like literally, with the O3 model seemingly being like very close to AGI. And all the while, there seems to be a very limited job for even the PhDs graduating. So it seems to be a bit weird here. If you want to have an idea of the hype, you can take a look at this Sam Altman blog post reflection of like what's up. It kind of encapsulate what the heck was happening. Like as people were just kind of fooling around a bit. They're like, yes, they were fooling around in a clear direction, right? But then I remember clearly that moment where like ChatGPT was out. Right? They saw it on Twitter and they're like, oh, this is nice. And then you can chat with it and oh shit, it worked. Because before that, there were many attempts. Galactica was one of them. I don't know if you remember. You can like it was a LLM from Meta that was trained on like research, and you can converse with the research. You can ask it how to make crack cocaine and stuff. And it was shut down. And then directly afterward, you had ChatGPT, and then this like went through the roof. So like that's kind of what kicked it off, but it was never like a concrete effort. And now OpenAI has to work around the clock to make a product company out of it. The interesting part is the last bit here. You see here, we are now confident we know how to build AGI as we have traditionally understood it. We believe that in 2025, we may see the first AI agent join the workforce and materially change the output of companies. We continue to believe that iteratively putting great tools in the hand of people led to great broadly distributed outcome. So, we're beginning to turn our aim beyond that to super intelligence straight up. AGI is done. Like, it's already in the roadmap, guys. We're done with this shit. We're now like looking for super intelligence in the true sense of the word. We love our current product, but we are here for the glorious future. With super intelligence, we can do anything else. Super intelligent tools could massively accelerate scientific discovery and innovation well beyond what we are capable of doing on our own, and in turn, massively increase abundance and prosperity. Just that. That's if you thought AGI was the top of the hype, we're on the super intelligence train now. Buckle up, everybody. It's important to understand a bit the whole dynamic at the moment and take a deep breath. We're in a sort of bubble, yes, propped up by the likes of OpenAI and Anthropic.
The next big question that we're all asking, I can't even believe we're just asking it 2 years later, and you actually just wrote about it. You said that it is possible that we will have superintelligence in a few thousand days from now. 2 years ago, did you think that? And when you say a few thousand days, I can do various versions of math on what that means.
I think it's possible, and I think it's possible not super far in the future. I expect that in 2025, we will have systems that people look at, even people who are skeptical of current progress, and say, wow, I did not expect that.
But you were asking when will we get this?
When do you think? What's just put numbers on
so
the
you know
table.
this is of course the thing I've been grappling with for many years, and I'm not at all confident. If you just kind of like, and this is totally unscientific, but if you just kind of like eyeball the rate at which these capabilities are increasing, it does make you think that we'll get there by 2026 or 2027. Again, lots of things could derail it, but I think it could happen on schedule. I think there could be a mild delay.
It's not the first time that the deep learning field is in such a situation, and won't be last. The tech job market is also acting weird these days, if you look at like what happened in the past 20 years. Overall, there are less jobs out there, and most companies are going for very senior candidate and reducing their R&D spending. So let's hear it from Theo, who is in a very interesting position here of hiring and helping other people get hired in very technical role.
I try to not make a ton of videos about getting a job in tech, but with the state of the market and how tough it has gotten, I think it's worth sharing my thoughts. I just had a conversation with a bunch of junior devs yesterday, and before then I did a talk at a college that really showed me how rough things are for people trying to get their first job, or even those who were laid off and are trying to get a new one. It's rough out there.
What you have to realize is that both things will pass in due time. If the AI bubble does pop into a full-blown winter, it doesn't mean that deep learning was just a fad. It's just that the current architecture was not the holy AGI grail we were looking for. And when the tech job market will recover, chances are that deep learning model of various sort will be much more ubiquitous in all businesses. Therefore, in my opinion, you should still learn how this technology work and how to apply them. Okay, enough of that. Let's get to it. Here's how you should go about learning deep learning in 2025. First off, learn to program. It's an absolute prerequisite. Yes, LLMs can write code for you, but the thing is that you should nonetheless learn how to think programmatically. The code is the representation of the program, not the program itself. You can create a program that could be implemented in various ways. Like, look at this, right? This is the advent of code 2024, right? And it's usually kind of difficult to do some of the more advanced things, but this guy decided to do advent of code in pure SQL. Like, it looked like this stuff, barely readable. You have to really work to understand the code. But this is not a program. That's never been it. Like the guy he's not thinking in SQL and trying to come up with the thing line by line. He has the program already built up in his head on a sheet of paper, and then he translates program into the code. And the code can be anything. It can be SQL, it can be Rust, it can be bytecode if like you want to write 1 and 0. It doesn't matter. The program is something else. It's living outside of the Silica realm. Learning how to develop a program is more of a way of thinking about problems and formalizing a solution that are correct. This knowledge will be very useful to understand where techniques like deep learning are helping, and will generally be massively useful for your problem-solving skills at large. For your coding language here, I obviously suggest you to pick Python since it's the de facto standard language for deep learning, and it's also very useful for other type of field. The course I recommend here is Scientific Computing with Python from FreeCodeCamp, because like there's many that you can choose from, and if you're just starting to learn the language, you cannot go wrong, I guess. But I like FreeCodeCamp and I like how they're running their stuff. It's a non-for-profit that is trying to teach you how to code, and a lot of people have gone through their project. You can earn certification. It's really a project focus. So I do recommend this one. Also, if you feel like doing some light introduction before jumping into a course, I highly recommend Brilliant, which are kindly sponsoring this video. Brilliant is a website with lots of interactive bite-sized lesson and problem to solve. They got quite a few interesting beginner topics if you want to refresh or supplement your learning across like math, programming, and even LLM, I think. I've gone through their programming courses and it's a very good introduction to the material. I like how it was structured around making micro program without overwhelming the beginner with jargon. It's bite-sized, so you can crack a few dozen drill questions pretty smoothly. So do check out the link in the description to test it out for 30 days and get 20% off an annual subscription. Okay, step 2, learn how to run a model. There is two ways of running a model these days. Prompting with in-context learning. This is done with foundational models with a large amount of parameters. And then the classical machine learning way of giving data as input and getting out an output in a predetermined format. This is usually done in a smaller models, but can also involve bigger specialized models. Prompting is not only limited to text. There are more and more models these days put out that have the same flexibility in the input as LLMs, but with other modalities. This way of running models, I think, will become more and more ubiquitous in 2025 with other modalities like sound, video, images. The classical way, in contrast, is when you jam some data in the model with a very well-defined shape and you get some predictable result out. This way is a bit more technical and your programming knowledge will be useful here. Still, it is the most widespread way of running a model in the industry. Learn how to do both properly. For the classical way of running deep learning model, I recommend the Practical Deep Learning for Coders course. It's a free course by FastAI. It's good because it's using FastAI, which is a wrapper around PyTorch, so it's very, very high level. But it allows you to run model in a very few lines of code. So this is perfect to get you to be the bridge between using deep learning model and then coding. This is good. And it's taught by Jeremy Howard, which is one of the best tech instructor I've ever seen. For the prompting, I recommend this video from Anthropic, those that made Claude. Really good. You can check it out. It will give you a good intuition about like how to prompt better. And I recommend this other thing, which is an interactive tutorial again from Anthropic that will teach you a bit how to do prompt engineering better. So it's over here. It's a bunch of notebooks that you're gonna go through. It's interactive. You're gonna use the Claude IQ, I think, and then you can like step through it and then do the work here. After that, it's all about like you building system with LLMs, and since you already used it, now you can kind of know a bit better how to work with these things. Third step, learn how to train base architecture. Training preset architecture is pretty straightforward. If you followed the FastAI course I recommended, you should already have a pretty good sense about how to do this step. At this point, I recommend you to like pick a framework, PyTorch or TensorFlow, kind of doesn't matter. I would go more toward PyTorch, right? Just because with FastAI, you already kind of used it. And you dive into the tutorial section, they both have that. And then you find the modality that most interests you. So if over here, you're interested, I don't know, with image and video, right? You go and do the torch vision, object detection, fine-tuning tutorial, and then you go through it and you can understand a bit better how to do that and work with these base architecture, and you're going to train some model out of this. Here you're going to fine-tune them, but then you have like a different type of tutorial for very specific deep learning task. Once you know how to train a model, which is not terribly complicated, you can then study architecture and their differences. And that's step 4. You finally dive into the theory and fundamentals. When you get to this point, you should have a very crisp grasp of the context in which your model are evolving. The goal here is to iteratively increase the resolution you have on all of the components of a deep learning architecture, culminating in being able to read the latest research papers without being too lost. For the deep learning theory, I recommend the deep learning book. You can find the HTML version for free over here. It's good because it gives you like the foundation at a high level. It's not going to be like drilling you with like complicated math. There is some math in there, but it's not that complicated. And then you go through it, and at this point you can have like a good idea of the field as a whole. And here at this point, I do suggest you to pick a niche of deep learning that interests you the most, and that you dive into that field and the research paper after the book. So then the flow, usually how it goes after this, when you learn a theory, is that you focus on making projects and stuff like that. But then once you hit something that you're using, let's say you're using ResNet, and you're like, wow, it looked like very complicated, but I'm just using it like this. I wonder what it is for real, and what's the difference between like this version, this version, this version. Then you do the following, which is you just open up the paper and you start reading about the stuff. And you're gonna see, since you have the foundation, since you have like the practical knowledge about the thing, it's gonna be much easier for you to understand like, okay, well, what is happening here. You get an intuition a bit more, but then you're gonna be able to read all of this without feeling too lost. And now you can understand, oh, okay, when they are talking about like the different layer, this is what they're talking about, this mix of things, and then you can see the different trade-off that happen in there. But then you get a very keen sense about like what the hell is happening. To conclude, make sure that you have a clear why guiding you throughout the year if you want to learn deep learning in 2025. This stuff is fun, but it can get pretty demotivating if you're wrangling a complex methodology for a while without any sort of headway. And that's it for today. I hope you enjoyed the video. Don't forget to like if it was the case and leave a comment if you have any question. I'm here to help. Have a great week, everyone, and see you in the next video.